Hi everybody, this is Algebra 2, Lesson 8. This lesson covers polynomials, graphing linear equations, and the intercept-slope method. Alright, so a polynomial, we're going to go over a lot of terms in this lesson, but these should all be review from Algebra 1. So first off, a polynomial is an algebraic expression with one or more variables having only terms with real number coefficients. So what's a coefficient? The coefficient is your number part that's being multiplied, right? So that part's your coefficient. Okay, and a whole number powers of the variable. So here's your variable. That's your letter part, right? And your number part's your coefficient. Your letter part's the variable, and you have to have a whole number power. So you can't have like x to the 1/2, right? That won't work. Okay? Alright, so your coefficient is whatever you're multiplying times your variable. Your variable is your number, and you have to have whole number powers on your variables, and you have to have real number coefficients. Alright, and then it's a polynomial. Polynomials with one term are called monomials. So here's one term. Okay, a term is each part that is separated by a plus or minus sign. So that one's a monomial, that one's a monomial, that one is, this one is not a monomial. If it has two terms, it's called a binomial, and three terms is a trinomial. This one right here is a trinomial because we have 1, 2, 3 terms, 3 parts, each one separated. The degree of the polynomial is the same as the degree of the highest degree term in the polynomial. That sounds confusing, but it's actually really easy. Okay, so degree just means what's its exponent. This one is 1, right? Because it doesn't have an exponent, right? There's no exponents. It's to the 1 power. This one would be, no, actually that one would be to the 0. This one's to the 0. The degree of this one is a 1. The degree of this one is 2. And the highest exponent, which will be right there, which is 2. Okay, super easy. An equation that contains only polynomial terms is called a polynomial equation. The degree of the polynomial equation is the same as the degree of the highest degree term in the equation. So same thing. This one would be a first degree because all these are just to the 1. This one is also a first. And this one's also a first. The graph of a first degree polynomial equation in two unknowns is a straight line. So two unknowns, I have an x and a y, right? I have two variables. And none of them are squared or anything higher than that, but none of them have any exponents, right? So that means that when I graph this, it's going to be a straight line. Alright, so how do we graph it? Graph 2x plus 3y equals 6. So first thing we're going to do is we're going to make a little chart, an x and y chart. And we're going to come up with numbers and feed them into this equation and see what we get, right? So if we said that x was 1, what are we going to get if we put 1 into this equation? So if I said 2 times 1 instead of my x, right, we want to plug numbers in for x and see what we get for y, plus 3y equals 6. 2 times 1 would be 2, plus 3y equals 6. Now we're going to do minus 2 on both sides. We're going to get 3y equals 6 minus 2 is 4. Divide by 3. We're going to get 4 over 3. I don't like that. I don't want any fractions. So I'm going to get rid of that. Oh, I know. Easiest one to always do first is 0. Alright, so if I said 2 times 0 plus 3y equals 6. 2 times 0 is just 0. Plus 3y equals 6. I just need to divide by 3. 6 divided by 3 is 2. So y is going to equal 2 when x is 0. All right, let's try another one. Now, if I look over here, I can see that my x term and my equals term, like both of these that aren't connected to the x right there, the y term and this other one, are both divisible by 3. So if I use 3 as my x, it's going to come out even. So if I put 2 times 3 plus 3y equals 6, 2 times 3 would be 6, plus 3y equals 6, and then I'm going to subtract 6. Oh, I don't know if this is going to work. 3y equals 0. That just means y equals 0. I think that works. We shall see when we go to graph it. All right, let's try another one. Let's try 6. 2 times 6 plus 3y equals 6. 2 times 6 will be 12 plus 3y equals 6. Minus 12 on both sides. Let's see. Okay, 3y equals 6 minus 12 would be negative 6. Divide by 3. And I'm going to get y equals negative 2. I've got negative 2 right there. All right, I could keep going, putting in any numbers, even if I come up with fractions. Any number I put in for x, I'm going to come up with something for y. But that's enough for me to graph. Really, I only need 2 points. So now I'm going to graph this. So I need, this is my x axis, this is my y axis. I need my x to be 0 and my y to be 2. So on my x, I'm going to have 0, that's in the center, right? And my y is 2, that means I go up 2. So my first point is 0, 2. Put that right there. My next point is going to be 3, 0. So on my x, I'm going to go over 1, 2, 3. And I'm not going to go up and down at all because it's 0. Then my last one is 6, negative 2. So I would need to go over 6. I don't have enough room. This would be 4, 5, 6, about right there. And then I would go down 1, 2, and I would be there. And you'll notice that these make a straight line. My line wasn't very straight, but let's see. I think there's a thing I can use here to make a straight line. I'll just draw a line. Oh, that's a curvy line. We want it straight, and we want it to be blue. And there we go. And it makes a straight line. So that's how you graph. In this next part, I'm going to show you how to graph a different way. Wish it would stop doing that. Okay, so this one, we want to use slope-intercept method to graph the equation. Now, slope-intercept method is a much easier way to graph than making the little chart. And really, it just depends on us knowing what these different numbers mean in this equation. So I've got 2x plus 3y equals 6. What I want to do is put this into slope-intercept form. And slope-intercept form is y equals mx plus b, right? So I need my y term to be first. So I need to get this onto the other side of the equation. So I'm going to subtract my 2x from both sides. And I'm going to get 3y equals negative 2x plus b. Now, I'm almost there. Y equals mx plus b. So my y term has to be first, then my equal sign, then something multiplied times x, then my term that doesn't have a variable. All right, so I've got my y term, I've got my equals, I've got my x, and then I've got my plus b, which will be plus 6. Right, because of the 6 right here. Okay, so I'm just rearranging this equation, right, because I want my y to be by itself. So I just move that to the other side. Okay, now I have to get y completely by itself. This is 3 times y. So what I'm going to do is divide by 3 every single term in that equation. And so now I'm going to get y equals negative 2 over 3x plus 6 divided by 3 would be 2. Okay, so how does that help us? Well, once we know y equals mx plus b, if we know what m is and we know what b is, then that will help us be able to graph really easily. So m is going to be our slope. And slope is always rise over run. The rise tells us how much we're going to go up and down, and the run tells us how much we're going to go back and forth. So our rise is our change in y, and our run is our change in x. Okay? That just tells us how slanty our line is. What is b? The b part is our y-intercept. That just tells us where our line crosses the y line. Okay, so at some point it's going to cross that y line. And whatever that b is, right, that's where it crosses the y line. So for this one, it's 2. So that means I'm just going to go up 2, because it's positive 2, and make a point right there. That's where it crosses our y line. That's our y-intercept. And then if we know our slope is negative 2/3. Okay, so if our slope is negative 2 over 3, what does that mean? This is our rise, and this part is our run. So that means we're going to go down 2 because it's negative, and over 3. Okay, so we're going to go down 2 over 1, 2, 3, and put a dot. Or we could move that minus sign to the bottom. It doesn't matter if it's on the bottom or the top. Now we go up 2 and backwards 3. Right? We go the other way 3. So we go up 1, 2, and backwards 1, 2, 3. And you see how we're still on the same line. Then we can draw our line. We'll make it purple. And really that will keep going out forever in both directions. And there we go. That's how you graph using Intercept-Slope Method. So you're finding your intercept, your y-intercept, and you're finding your slope, and then you're just graphing the line from there. Let's try another one. Use Intercept-Slope Method to graph the line y equals negative 3x minus 3. That one's already set up for us. We don't have to change it around. All right, so we know that it's y equals mx plus b. Okay, m is our slope. So we just need to find our m right here, which is negative 3. So if our slope, right, if we look at this, it's already set up as y equals mx plus b. And our slope is the one that's connected to our x term right there. So that's negative 3. And then our y-intercept is our b. That's right there. And that's also negative 3. So that means I'm just going to stay on my y line, right? So here's x. Here's y is my up and down. I'm going to stay on my y. I'm going to start at 0. That's called the origin right there, 0. And I'm going to go down 3. 1, 2, 3. So there's my first point. Then I'm going to start at this point, and I'm going to go by my slope. My slope is negative 3. You can turn any number into a fraction. So if I have the whole number negative 3, that's really negative 3 over 1. Negative 3 is my rise, and 1 is my run. It's going to be hard for me to go down, so I'm going to move that negative part to the bottom, right? So that means I'm going to go up 3 and backwards 1. 1, 2, 3, and left 1. 1, 2, 3, and left 1. And there's my line. And then I can just draw a line from there, connect those points. Like so. And they turn into a lovely straight line. And there we go. We graphed that one. Now you'll notice something, that if your slope is negative, if you're going from left to right in that direction, negative slopes go downhill. Positive slopes are going to go uphill, right? So if this was positive, if we had y equals 3x minus 3 instead of negative 3x, all right, let me graph that one in a different color. So if we were graphing y equals 3x minus 3, right, our intercept is still going to be right here. That's our b. So that's still going to be negative 3. So that'll be that same dot. But our slope would be positive 3. And that would be 3 over 1, right, if we turn that into a fraction. And that's going to be our rise over our run. So that means we would go up 3 and over 1 to the right. Up 3 over 1 to the right. So we would have a new line. That went the other way. Right? So that's a positive slope. All right, so this one has a positive slope. And it goes uphill. Our negative slope goes downhill. Right, so it's going down, and our positive is going up. Okay? Go ahead and pause the video and work the practice problems, and then I'll come back and work them for you. Whoopsie. Okay, so there's only one practice problem. And it says use slope-intercept method to graph this equation. All right, super easy. Whoops. All right, so we got 3x plus 4y equals 12. We're going to have to rearrange that. 3x plus 4y equals 12. We got to get our y over here by itself, so I'm going to subtract 3x from both sides. We get 4y equals, now I can't put my 3x and my 12 together. They're not like terms, so I'm going to have negative 3x plus 12, because it's a positive 12. Now I have to divide every term by 4. And I'm going to get y equals negative 3/4 x plus 12 divided by 4 would be 3. Okay, so now I can tell where my slope, my y-intercept is right there. So that's my b, right? It's my y-intercept. And then my slope, m, right, is right there because it's y equals mx plus b. You definitely want to remember that. Say it to yourself every time you do one of these. Y equals mx plus b. And then your m is your slope. Okay, so first thing we need is our y-intercept, or b, and that's positive 3. So we just go to the center and we count up 1, 2, 3, and make our dot. Then from there, we're going to figure out where this goes. So if our slope is negative 3 over 4, negative 3 would be our rise, and 4 would be our run, or we could do it the other way around. We could do positive 3 and backwards 4. We're going to go down 3, 1, 2, 3, and forwards 4, 1, 2, 3, 4. I don't think I made my diagram big enough here. 1, 2, 3, 4, like that. And we're going to have to plot this just using 2 points, which you can totally do. All you need is 2 points. As long as you got 2, you're good. And that's what that looks like. And there's our line. So your diagram should have looked a little bit like that. You're definitely going to want to get some graph paper because your homework's going to have a couple of graphing problems each time. All right, that is it for Lesson 8. Thanks for watching.